Yeah, and welcome back for yet again another unrehearsed video. This time we're going to be doing LFRT. Um, this is becoming quite popular for various reasons, it's an alternative to real-time global illumination. I might also, as a bonus at the end of this video, show how to properly set that up as well. But for just starters, I'm gonna walk you through how to set up LFRT. Um, Now, the end reason to use LFRT would be because it does perform a little bit faster than real-time global illumination, as opposed to the way RTGI works. Well, I guess they both do operate explicitly in shader or in GPU, but I noticed that global illumination can be very buggy still, but it also does extra work that doesn't quite look as good as what LFRT has been doing these days. LFRT is more of a direct like light source system rather than an emission system in essence. So I think there's obviously maybe math differences to it and everything as well, but not very sure. But point is LFRT. So what does that even mean? It means light from render texture. It is something I just pulled out of my ass and made up. Yes, but it's caught on as its name, so that's what it is. Um, it uh, it basically is just a means of taking a render texture and creating a light source from it. But in this particular case, the way I set up my shader was to be 8 by 4 light sources. So it's a grand total of 32 that emit from the screen based on the screen colors. So let's start by creating an empty project. We're gonna create a VRChat world, people. Yeah, let's do this. We'll call it LFRT demo. There you go. So there's that, and we'll go create. Let's go. Let's do it. Ah. Okay. I'll stop being dumb. Oh wait, we have one small problem. I already goofed. I'm gonna go ahead and do this number. Details, Unity is up. It's still trying to load. Unity die. There we go. So I did goof. Let's fix that goof. Just going straight to here and LFRT demo. I created it in 2022 alpha, which, yeah, we don't want that. The current version, before they switched to 2019 431, it should be 2019 430. Let's go ahead and try it again. So 430, LFRT demo. There we go. Put a hyphen in it. Then I'll get around this delete and I'll just tuck that off screen for now. It'll be done eventually. I created a lot of garbage just for a new project. Man, that's scary. Okay, so new project building. There we go. New project. That was a lot faster than 2020 or 2022. So here we have our scene, our sample scene. Let's save this scene before we lose it. Okay, assets, scenes, LFRT demo. Must be consistent at this point. Get rid of the sample scene. We're probably not going to want this stuff. I mean, this could be our reference camera, so we'll call it reference camera. And just to think ahead, I'm going to do RTGI demo as well. So now I need a world. Uh, I could use a box, but I think I might already have. Let's start with importing our assets. So my shader, import. That should be all we need from this. And then VRChat. Install the newest SDK worlds. There we go. So the one I just installed was 2021 93925. There might be newer, but this is just the newest I have downloaded for this video. Just go ahead and let that import. And then we'll need, we can close this. We'll probably need Udon Sharp, of course. Oh, it's currently importing. Let it finish doing its job first. Do, 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 do. I will hold out in installing Bakery, and I'll tell you why. Because if I install Bakery now, RTGI won't work. There's a bug with it, a weirdness to it. So for starters, I'm going to bake the LFRT scene with Progressive, but it would make no difference if you baked it with Progressive or Bakery. Just as a forewarning to what we're about to see. Yeah. It's still importing. Okay. I believe that is SDK3 imported, maybe? No? It still wants to import more. More import. More import. Oh, really sorry about the wait here. This is unexpected. Well, I guess a little bit expected, but just not as long as this. But yeah, Udon Sharp now. There, that's next. And for this demonstration, we're going to be using Merlin's player for Udon Sharp as well. So the Udon Sharp player or U Sharp player. And again, versions, we have Udon Sharp 0.20.3 and in U Sharp Video version 1.0. I'll throw links to all this stuff in the description, of course. Okay, and now finally the video player. Ta-da! There we go. So for starters, we need some kind of box. I think I had a inverted box somewhere, but I'm not sure. Let's just do a scan for mesh. What meshes do we have? Cube prototype, VRC, these are all. So uh, just for the sake of creating a world, I'm going to start with opening Blender here, just so we have some kind of world to put everything in, and Blender. Simple, we'll just take out the light and camera, delete it out. This thing, we'll just do flip, flip normals. There we go. And then we'll do I don't know, scale x by 2, scale y by 2. And it gives us a typical movie theater shaped box. I don't care if it's necessarily accurate. Let's go ahead and actually take a look to make sure this is the right way around because it's important for UV mapping. So yeah, we click on the material, click backface culling, there we go. Show the material, there we go. And you see that, yeah, we see an inverted cube. And that's what we want. So we'll file export FBX file. This is not a necessary step. I'm just creating a fake world. So just another warning, this is not necessarily something you, the user, will have to do. This is, this is the point where you would actually just be importing your world assets. And we'll create, we'll call it world. And we'll have all of our stuff that pertains particularly to this world, this VRC world in here. And let's see, just grab that particular folder. There we go. Blender. Go straight directly there, and we'll call it world.fbx. Sure. Right. Done. Don't save. Doesn't matter. There's our inverted box, and there's our inverted box. And create material. We'll also call that world, and it'll just be a plain old material for the world. There we go. So for starters, let's check the import settings of setbox. Typical things we probably want mesh compression high and that. Okay, you're going to want definitely properly set up light map UVs for your world. So make sure you either generate them in Blender or you tick this option. And I like to just crank that way and these this way because I'm crazy. I don't know. And then click apply. Yeah, tangents should be imported. Blend shapes should be imported. Legacy blend shape normals because smoothing angle, this doesn't particularly matter, but it's usually 60 is about good. But this really normally should be imported. And yeah, there we go. And there's our little box. And we have world assigned to the material, but just in case, drop your world there and there you go. And then we can switch this over to my shader, the light from render texture. And just, there you go. Just pop. So now we need the actual video player. This actually gets pretty simple. Let's just drop that player in there. So obviously our box is a little too small for the player. This is probably too small for a human player. So yeah, make that maybe a bit bigger. 800. No, that's way too big. 400, 400, 400, and maybe too tall. Nope, never mind, just fine. We could make this a real VRChat as a demo, so I'm going to push this, or go ahead and push this up by 200. No, 1. 100? No. Wait, why am I saying 100? Like 2. Oh, how many meters tall is this thing? Okay, so that's, we probably don't need an 8-meter tall world. So let's do 2 and then 200 for the height, except that's not the height. That's the height. There we go. But it's still too wide, really, for a video world. So we'll do 300 in there. There we go. Now we got a nice little video player room. And let's grab that player and get it in place. Tuck that somewhere nice and cozy. Not sure why it's so huge. Maybe I should still make it bigger. Okay, we'll follow suit with 300, 300, 300, and then put that up at Y3. There we go. We'll just have that nice and centered into the room. Looks like actually about right there is fine. Maybe I like, just because I like more defined numbers there, I'll do that. Okay, so here's our player. Let's go ahead and make a world descriptor too. So on our there, we can say VRChat world. Well, I don't know. We can call it the keeping suit. Well, no, that's fine. VRC world. Scene descriptor. I'm a dork. They don't call it worlds, they call it scenes. Okay, so we need a reference camera. Well, I'll add that reference camera. And we need a spawn point. And we'll just go ahead there and call it spawn point. And just tuck that, like, yeah, back there is fine. Oh, that's outside of the world. There we go. Don't know why. Okay, this should be 000. This guy should bring that there. There we go. -5. That looks good. All right. That'll be where the player comes into the world. All right. So we got a spawn point. We have a world. We have our video. So in essence, we have a VRChat world. Nothing really fancy going on here. Now, we probably want to set up some initial lights before we render anything. So we'll go ahead and create. Oh, wait. Well, there is one other important thing. We're going to go ahead and add add component, a box collider here. Obviously, we don't want players like falling through the world. So here's our box collider. Let's go ahead and just let's say size right down here. We could say 10, 10, 0.1. No, it's 0.1 here. 10. Go a little bigger apparently. 2020.1. Yeah, I did it wrong again. 2020. There we go. So there's a little platform for players to stand on. For now, we're not going to really box in the whole thing. And this is 0.1 tall. Make sure that -0.05 then, so that way it's right under the player's feet and they're not like stuck inside the box. All right, that's the world. Now we can add, like I was gonna say here, maybe, and I don't know, I'm picky about. Yeah, it doesn't matter where that goes, I guess. But you can add, what is it? Yeah, cylinders. So this cylinder is going to be a special kind of cylinder. Just so that way when we bake, we have some kind of lighting in here. I'm just going to kind of create a little fake backlight, something that just illuminates the room. So 0, 0, 0. Rotate that 90. Nope, I should still say 90, 90. Okay, I'm going to make it, let's scale that up to, nope, 2, 4. That should be good enough. And then we can do 0.1, 0.1. We got ourselves a nice little light bar. We can put this like right in the back of the room, so there's something to illuminate and allow you to see without having trouble. And in this other case, let's go ahead and add some light probes. I'm just going to leave the 4 here and then dead middle generic. I don't really particularly care. Maybe like raise it up out of the ground at least first. Like 1.1 should be fine. Get those probes out of the ground. Actually, go ahead and get it up in the air, I guess, like that. Those be where your avatar basically samples light from as ambient light. Lighting, obviously we're not going to really want a skybox for this thing, so let's just get rid of that and set this to color, black. This is a lighting tab, seen by the way. And then we're not going to turn on this yet because we're not using it, but we want baked global illumination obviously be turned on. We're going to use progressive GPU for this as the demonstration. And actually, for all intents and purposes, it's mostly set up, but this light isn't. So this little light guy, let's come here and we have world, but let's create another one. Material light. So cylinder light. So if you want this to stay my shader and you want my shader, like if you want all this just to be one shader and not have like different shaders going all over the place, you're gonna have to do a little trick here to get this to actually be a light. Click emission and turn this to white. So turn emission on, then turn it to white. And then you can switch over to light from render texture, and it'll be that. But we have one more extra step though, because now we have to enable the detail layer and say that it's unlit. That gives us the light color and a light value. It's not something I've really documented yet on how this works, but the combination of these two will turn this into an emissive layer, basically. So once it's turned on as an emissive layer, you can come to the light enhancements section here, and enable emission should be turned on, which it is, and emissive boost is 1. So now when we bake, we get some fancy stuff. So now we wait for the bake. And it looks like it's going to take a bit. So let's actually simplify this. We don't need fancy lighting for this test. I'm not sure what it's doing to the video when I bake it with progressive GPU. It's probably chopping up the video. Hopefully not too bad. But I'm going to drop this down quite significantly. Let's say 4, 50, 50, 1. We only need 1 bounce. Okay. Filtering can just be auto. Texels, we can say 5. We don't need it to be too big. Oop. And light map padding is whatever smallest you can get. 256 for light map size should be fine. And now we can just let that render, and should render nice and fast. Interesting behavior. That's because I'm a dork. You set that to static. Remember to set your baked materials to static, otherwise you won't get baked. And that goes the same for this light bar. It should also be baked, set static. Technically, it doesn't even need to do that though. It can just have contribute GI turned on. But since it's not going to move, just set it static. So lighting, generate, here we go. We still don't quite have the desired effect. Did we get baked lights? We did. Did we get real time? Of course not. Yay, unrehearsed. These are the things that happen. So I'm not like, oh, that looks nice. It did actually do a thing. I'm just a little confused as to why the whole thing is nice and lit up this way, though. Oh, you know why that probably is? Light from render texture technically doesn't have render texture in it yet. So this is where stuff starts to get fun. The first thing you want to do is take your screen. Okay, so we open the material here for world. Technically world and light should be fine. Control clicking and selecting both of them this way is all right. Then click this lock panel so it doesn't move around. Open light from render texture here. We can click on the U-Sharp video screen, find screen, and bring it into the set from transform. Click set. That sets the position of the light location. Strangely enough, it didn't look like it took, but interesting. It doesn't look like it wrote properly. So I guess let's just go ahead and make sure this gets to the right places. So 5.95 on that, 5.95 on that. So the next thing we need to know is this, the size, the scale. I don't have an automated tool for setting this yet, so what you need to do is copy, well, this actually gets a little more complicated because this video screen is not set to 111. Let's fix that. You should have this at 111 like that, so it's not off scale to anything. So that fixes that bit. We'll want to update our position now too. In this case, I mean, it might just be easier to just do one than the other if it's not going to work, like that one, and then that one. There we go. So now we're back to the screen and its size. We have 7.6 whatever there, and the Y 4 point whatever there. So what we need to do is on this, on light from render texture. The idea with the spread is it goes based on the direction it's going in. So if we click this, you'll see X. It's moving along the X-axis, right? So that means the positions that would matter to us are X and Y. Y is always going to matter. X is going to matter in this case. If you want to tilt the screen like this, where it's an off angle, you're going to have to do the calculations, which can be a little rough to figure out from the transform. But if you just make it 90 degrees like this, then you put in the values we're about to put in along Z and Y. So flip it back to normal, and now we're X and Y. So clicking on world, light from render texture, we want to set up the spread. We put the X value that we took earlier in here, divide by 2. That part's important. Copy, paste it again to Y. Make sure to do a slash, which is divide, and 2, and press enter. You end up with 3.8 and 2.14 there. Okay, so light, same deal. Put those same values in place. Divide by 2, and divide by 2. All right, so now we're starting to see the light become a thing, even though there's no actual light here. So let's go ahead and select both of these yet again. Open the light from render texture tab. In this guy, we can set the intensity of the light. 1 is already pretty bright. 10 is our range. You can see it's starting to behave more like an actual set of lights. So we want it to reach obviously like to the back of our room, and maybe just kind of give it a light bit there. This is all to flavor. You can figure out how you really want to do this yourself. We could also set an intensity. I kind of do like to bump it up just a little bit, but it's recommended that you set it to 1 or lower, just because some people don't like bright lights. And there you go. That's so far the main component is setting up the shader. Once the shader is set up, now we have to set up the video player. The video player has one exception to it that we have to add. It's the video itself isn't going to give us the render texture we need, so we have to like tell it to give us the render texture it needs. Thankfully, Merlin created a component, and it's called the output render texture output. And then we get the render texture output component on here. We could just put that right on the player. Obviously, the first thing it asks is for itself, the player. So there we go. And then an output texture. And we'll set that up in just a sec. I am going to actually quick grab a video to use for our demonstration. Probably actually better this first one then. So let's go ahead and add this URL into here. That'll be our demonstration for this. You can also set this screen up a little differently as well. You can change the standby texture, which is nice to do. And let's go ahead and use my kitty. Yeah, okay. And I mean, just for the visual effect, we could also do that here, I suppose, too. Just so we can see what it's going to do with the texture. All right, so there we go. Now we need to create that render texture. So coming back to the component, sorry for the distraction. Where we left off was we added this. We added the U# video player. Now the next step is to set up output texture. Set up output texture. The knee-jerk reaction is to set this up to 1920 by 1080 or 1280 by 720. You're thinking, oh, I'll put the whole thing and then it would affect the video. This doesn't affect the video in any way. What you really want to do is set it up to 8 by 4, which is the internal resolution that we need for the light from render texture, the render texture for our shader input. Then create texture. Here we are in LFRT demo. We can just put that in world and just save it there. Okay, and this is done. So now we can take the other two materials here. Oh, this is peculiar. Interesting. But we'll ignore that. It's just as a demonstration, so no big deal. So texture and light from render texture, we can now set it to our nice newly outputted texture. And you see, is dark. This is what should have happened. And I got a nice little bit from the light there too. Okay. This really should get set to black though, shouldn't it, by default? I'll probably have to change it at some point. And we can save, and I believe, fingers crossed, we have a VRChat world. A VRChat SDK, show control panel. I'm gonna log in. There you go. Account manager, we don't need to do that. Right, setup layers. Right, so we don't have everything set up either, thinking about it. So let this do its thing, of course. But there's a couple other things I've failed to mention to set up, and one of the most important ones, getting this to work with your avatar. this all works, and if we hit play, you'll see. Oh, I don't know if Merlin's component is working though. Or at least this should be. We have some interesting issues here. Is this texture even updating? Doesn't look like it. So that's a small problem. Oh, you know why? The big important button here, convert to UDON behavior. Set that player. I don't know how that got unset either. That's interesting. Now hit play. Doesn't look like it. Oh, there it goes. Loaded that video. And there you go. The light from render texture is set up, but we don't have players yet. So let's go ahead and pause that. The first thing we're going to actually want to do is in our layers, we're going to want to add a layer here. Layer 22, we can call it video. This is how we set it up for the players, by the way. So we start by creating this layer that we're going to need. It's a required layer for a path for the screen. So now we go over to my shader. In the LFRT folder, there should be this LFRT avatar light. You want to drop that in place in front of the screen. You'll see that it's this box. It default wants to fit over the screen is basically it. So I want to get rid of this or do a better texture than this, I think, for something to make it a lot easier to see. We'll go ahead and use, VRChat Unity SDK. Why not? Okay, so take our avatar light, bring that back. Right. Before we even do that, the point of making the layers, now we select the video screen and we actually switch the layer of the video screen to video. And then our LFRT light and camera, because it's actually a camera as well. We bring that X is going to be 0, so let's do that. Okay, so there, it's kind of tucked over it. 5.95 is about like, the usual goodie in that. Looks like, it's still outside of the world. So we need to bring that back in. Why am I losing my handle on it? Interesting. Give it focus, and I guess it likes it. So bring that to about there, which looks to be in this case, 5.75. Maybe closer. 8. 8 looks good. Center the screen about, so what is that, 2? Oh, might be better to just look at the screen, 3.44. So put that right at where the screen is, 3.44. Same height. Right, so it's sampling all that, but you notice it's sampling a little more than we need to. So we put it at the center of the screen. matching most of the parameters. Obviously 5.8, video screen is 5.95. We want to pull it just a little bit away from the video screen. The camera, let's take a look at what it's capturing because it looks like it doesn't show anything right now. So it should be capturing video. So culling mask needs to be set to video. There you go. Now you see it in the camera preview. Camera previews on graphic. Okay, size. Size is where we change it. 2.4, too small, 2.3, 2.2, 2.1, and whatever it is until we get it nice and filled in there, basically. Don't want it to have anything over the edge, any black spots over the edge. Doesn't matter mostly in the end because this is just going to be sampling a small resolution texture anyways, and the resolution of that thing is 8x4 as well. So yeah, I think maybe it actually might behoove us for the sake of the direct light now. I'll change this. On the fly coding again. So we do colors.length. So it doesn't matter what the render, that new render texture is and size. Oh, but it is 8x4. So let's do 1.1. Right. I'll commit the changes and make sure to update the package as well. It looks like I goofed and oversampled in that case. When now, because we're dealing with just a camera for the updating the direct light, we can actually have it smaller. So I'm adding an extra optimization as we go through this. And we'll set the direct light to use this avatar texture. I don't remember with this. Oh, right. That is important as well. So we actually have to edit this guy. Image size. I'm gonna edit. You don't have to do this, but I had to do this to fix it. I'm just gonna make sure it's 2x2. Save it. There. Now it's saved for you guys, and I'll set this also to 2x2. That way it's only sampling 4 total pixels and not doing all that. And there we go. So the render texture, or the camera, is now outputting to this text, which is 2x2. Obviously that changed our aspect ratio. That was goofy of me. So I need to fix the aspect ratio on this camera as well. Just trying to remember where I do that. I think it's W. So we do 16 divided by 9. Nope. Nope. No. Okay. Let's try the other way then. 9 out of 16. Too wide. There's the graphic video, okay. W is doing nothing there. Height is doing a thing, but odd. Set that to 0. And this, maybe this is supposed to be 9 divided by 16. Yes, it is. There we go. So I'll apply that. That's the new aspect ratio for the camera. You'll notice the camera says don't clear. That's important as well to this. Okay, so that should be all of it. Now it should also update this camera. There's another option here which has a default of 15. What this means, this little value means, which is important, is that it updates every 15 frames. So it starts with nothing, and then on the 15th frame that it renders, it'll update the direct light. This is important because of performance. If you overdo this number, it will drop and actually be worse than real-time GI and defeat the purpose. So keeping it around 15 will keep us, nice and happy. So let's create a player, by the way. 3D cube. Here's our little player. Let's put him on the player layer. Our player's on the player layer. Why the heck not? Just for fun, let's give it a rigid body. Kinetic has gravity. All right. Alrighty. Okay, so now we want to check. I want to quick check the direct light, just because this is a habit, I guess, to make sure everything is going to do as it's supposed to. Culling mask again here, same deal. Player, player, mirror reflection. Good. Important. Okay, so that's all default set up and configured. Our little sphere is just sitting in the room. You can see it sampling light probes, and it's just dark because the room is dark. So hitting play. So we already have a problem. It's not updating the color. Or is it? Direct light. I see no color update. It's the camera's getting that. What's the render texture getting? The render texture doesn't appear to be getting what the camera's getting. Okay, so camera, LFRT light. We've edited the wrong thing. Oh, there's the LFRT light. So it is getting its thing. Okay. So it should be updating our direct light, but it does not appear to be. But it is. It's kind of interesting. It kind of has troubles with darker rooms, I suppose. Looks like the video broke, so let's go ahead and give it a reload and see if it'll do its thing. This is resync button, resync button. There we go. There it is. Player. I think I might have bad math in my calculations here, maybe. Colors.length, reader, colors. Colors is 2 by 2, so it's total 4, and then we're all, aha! We're gonna have to do this a little different. 0.25. So I'll make sure to upload that as well with the corrected amounts. Hey, we're looking good so far. Nice and red. Look at that. Let's put our reference camera in a better place. Right, and hit play. Now we see our player, that unsuspecting little cube, and we see that it's getting light, and we see us getting everything, and look at that frame rate. Yeah, this is normally a lot faster, usually around 6,000-ish if I wasn't running this like with video recording, so that could be what's dropping it normally, or like right now. But that shows there it is, it's working. And give it a save. Let's see, anything else I'm missing before I upload this and give it a test? We got our world, we got our render texture. I'm going to go ahead and push this update, which I can't because I'm not in. Okay, I'll make sure to get it updated then anyways after the video. And yeah, let's upload this to VRChat. Oh, it thinks we don't have a spawn. I thought I said it. VRChat world. I also want to slip this in because it always drives me nuts. There. But spawns. There we go. 1. Okay. And set that spawn point. All right. Build and publish for Windows. There we go. And let's use that VRC camera. There we go. We'll call it the LFRT demo. What the heck, for people to see it. And what the heck, I'll even let it be in the community labs. I'll make sure to put a link to the world so you can see it live as well. And never mind my typo. Yeah, LFRT demo. I'll fix that from the website, maybe, if it'll let me. It took an unusually long time to upload. I'm not sure what the reason for that was. It shouldn't be that large, but I guess we'll find out. So let's start VRChat. All right, visit our worlds. There we go. with typo and everything. And look at that size. Oh, why did it take so long? It's only 395K. And here it is. See, it's also hitting me, hitting the world. And we'll find yet another video. Go ahead and use this madness. Set this to stream. Give that a paste. Here we go. It even works with the stream player. Interesting that the you can walk through our fake player. I was hoping to be able to just kick it around. What? I should have set the world to clear to black. But there you have it. That is the main portion of this video, and the point of it was just to show you how to set up LFRT. Feel free to follow along this video and create it in your own worlds. It should be as I just showed. And now we can move on to the next portion. Ooh, I like that bright blue. Easily distracted by pretty colors. Anyways, well, look at it. Okay. Not being distracted by pretty colors. Now we're gonna look at how to do the same effect with real-time GI. Boop. So we have our world. Let's go ahead and since it's all set up, we're just gonna go ahead and go to our scenes. There it is. Okay, an RTGI demo. So you're probably wondering how the heck were you supposed to set this up with real-time global illumination as opposed to LFRT? This screen should already have on it, and I should have actually turned it off for the demo, which I'll load that scene again in a second and make sure this gets turned off. But this little guy, yeah, this is. I failed to mention before I started the real-time GI portion of this that you need to turn this off. Uh, hopefully somebody will catch this after the other portion and realize that real-time GI update needs to be turned off for LFRT. It shouldn't matter that much, but it's just unnecessary extra work that the system is doing for just to update GI components that aren't actually there. Anyways, let's go ahead and switch this over to the required components and bits. We're going to change bits of this world over. So we have world. Right. Let's clone it, RTGI demo. RTGI Lite and RTGI world. Right. The only thing we need to do here, obviously, since it's all set up, is switch it over to just the plain version of my shader, or you can switch it to standard or whatever shader you want to use. One thing I failed to do was set up the sliding bit, so just set that up correctly. And really, there's not much else to this bit of it. So I can save. And now lighting. You want to tick first off real-time GI, and you want to switch this to enlighten. Save. We're going to go with, as usual, cruddy settings. You can obviously improve these for other times. Honestly, I would not improve these ever because once you install Bakery, that's going to do its own thing. So generate. Now we should have I see, it's still trying to generate. What? We can also get rid of the LFRT avatar light. That's not going to be necessary to this anymore. The texture itself is already moved as well. On the player, we have that component that we added. We can remove that as well. Don't need that. And that is real-time global illumination. This is only the first part of it if you want this to bake in your world with Bakery. You have to basically get it working like this with Enlighten before you install Bakery. If you have it already installed, just uninstall it, close Unity, reopen Unity, bake your scene in Enlighten, then install Bakery. So now we're going to go ahead and just right over to the asset store. bakery. There is a newer version of this if you paid for it. You can get it out of his Discord. There's some process to upgrading. Just follow along with that process, and they'll get you into the GitHub for this, where he has updates that are beyond what we are looking at. Interesting that this happened. What is it saying? Nothing happened bad. Okay, render GI updates. This is Udon chart. That's not okay. You can close that. So take just a bit, obviously, again, to install Bakery, but once Bakery is installed, it'll function with real-time GI. And I'll show you how to set that up as well. Okay, so Bakery is installed. Bakery, render light map. We want to go to experimental. Full lighting, directional, we can say baked normal maps is fine. Light Pro mode, L1. Probably important to this so we can get the scene updating, light probes updating. Atlas Packer, sure, but we're not going to be doing that. You can set that if you want, not really a necessity. You don't want to change UVs. That can get a little funky. Open image processor is fine. Update, and here's the important bits for real-time GI. Update modified lights in GI. Leave that on. Combine with enlighten real-time GI. Turn that on. It only turns on when you have it set to experimental. We can, like I said, drop this for the sake of the demonstration. Max resolution 256 min, that one bounce, like one sample. Just getting it simplified for this whole bake. Tile size, we can do like the same as the resolution. 256 should be fine. I usually like to set it to the scene name, like in the same scene folder, and then just click render. Sure, that shouldn't hurt anything. Yes. Did it? Okay, here we go. Now it's actually rendering. And ta-da! It's over here. Almost done. Ta-da! It's done and baked. You see the light also worked with bakery as well. It's that whole trick with my shader of making sure to set it to standard before you set it back to my shader. So yeah, setting it to standard, turning emission on, going back to my shader enables the emission effect if you wanted it. There it is. And then now if we hit play, you'll see the real-time GI version. And if we go to game, see it's about the same, but a little worse than if you were just to use LFRT. Yeah, there's some big dips in there already. And that's it. Hope that helps you. If you choose not to use LFRT, you at least can use this as a guide to how to set up, real-time global illumination. I know that's a bit difficult for a lot of people. Usually the problem that people run into is they've already baked their scene with bakery, and that they can't get global GI to turn on because whenever you hit play or when you upload it, it just doesn't function. This is because bakery was not configured with real-time GI turned on. So you have to come in here, you have to remove bakery, enable real-time GI, make sure you bake, do not use auto-generate, but make sure you bake, and then in real-time light maps, you see that your real-time light maps appear. You also see in baked light maps, lighting data will appear. And then once you have that configured, you can open bakery and then follow the steps that I showed you to set up bakery. Bake your scene with bakery afterwards. So good luck.